Maybe you've been teaching surface area like this, where each figure has its own individual formula, and there's so many different variables involved, you have to have a picture next to each one so that students know which things go in which places. That can be kind of confusing and a little overwhelming. Or maybe you're like me. I used to group prisms and cylinders together and pyramids and cones together. For prisms and cylinders, the lateral area was the perimeter of the base times the height, and the surface area was then adding the lateral area to the areas of the two bases. For pyramids and cones, the lateral area was 1/2 times the perimeter of the base times the slant height, and the surface area was that lateral area added to just one base. I thought I was doing great with this strategy, and it seemed to work well for the most part. But my students were like little robots, following along and plugging in numbers, but not necessarily understanding. And we'd always run into issues. What if one of the faces was covered up by another shape? Now my formula doesn't work anymore. And which part should I change? And what about this pyramid? I'm supposed to use the slant height, but because the base is a rectangle, there's not a uniform slant height. So now what? I knew there had to be a better way to do this. If you're teaching surface area, that means your students probably already know area of simple shapes like rectangle, circle, and triangle. And after all, isn't surface area just the area of the outer surface? So I did an experiment. I let my students pair up and I gave them a challenge. I asked them to find the surface area of this figure, but the only instruction I gave them was that surface area is the area of the exterior outer surface. And some pretty interesting things happened. Almost every kid noticed there were rectangles on the outer surface, and they already knew how to find the area of rectangles, so they were able to do that. Other kids saw that these orange rectangles weren't on the outer surface, and so they couldn't be part of the surface area. And for kids who didn't notice it right away, I had a really teachable moment. Some other kids saw that there were circles involved, and actually 2 full circles to be exact. Since they knew how to find the area of the circle, they knew how to find the surface area of those parts. The most challenging and interesting part were these curved panels. I asked students to think about what would they look like if you bent them open, and most kids realized that it would make a rectangle. They could get the height of it, that was 3, but what about the base? The base of this rectangle? Well, it used to be wrapped around the circumference of the circle. And my students knew that circumference was pi times diameter. In this circle, the diameter was 4, and the total circumference then would have to be 4 pi. But ours didn't go the whole way around. It only went halfway. And so then that would be 2 pi. And 3 times 2 pi, that was 6 pi. When it was all finished, some students had gotten it completely correct on their own. Others needed a little boost along the way, but everyone gave a great effort, and they seemed to enjoy the challenge as well. Then I let them in on a little surprise. This question I had given them, it came from the challenge section of our textbook, and I hadn't even taught them the lesson yet. But they already knew how to find surface area because they knew how to find area. And we all entered into the unit with a lot more confidence. And those old trouble spots we used to have, they got resolved. Students started looking at these figures as just simple shapes that they already knew how to find the area of. And if they weren't on the outer surface, then they didn't count towards the total. And that pyramid that didn't have a consistent slant height, not a problem anymore. We just had triangles of 2 different sizes. Even the curves of a cylinder could be broken down into parts that we had handled in the past. So do I still use special formulas to teach surface area? Sometimes I do, for cone or for sphere. But since I didn't use any new formulas for prisms and cylinders, it's not nearly as overwhelming as it used to be. So this year, when you teach surface area, maybe your formula sheet could look a little less like this and a little bit more like this, relying on the skills your students already have.